Most plant sensors either live in an app or disappear into the cloud. Now, I wanted something different. I wanted a physical, honest signal that tells me how my plant is doing right here without pulling out my phone. So today, we're building a simple but intentional ESP32 plant sensor and watching it respond in real time when the plant actually gets what it needs. This isn't an app, and this isn't automation. This is a physical sensor node that lives with the plant and gives immediate feedback using light when conditions change. So no guessing, no dashboards, just a calm signal you can glance at. So for the parts, we'll need a breakout board, an ESP32 module. We'll need a temperature and humidity sensor. Next, a capacitive soil moisture sensor. A level shifter. This is to shift the 3.3 volt signals that the ESP32 outputs to 5 volts. A BH1750 light sensor. A 16-bit RGB LED ring. A USB-C breakout board. This is to power our circuit. And finally, some 22 AWG solid core wire. This circuit is intentionally simple. The ESP32 reads each sensor at regular intervals. Soil moisture by way of an analog input, light by way of I2C, and temperature and humidity via a single data pin. Now, based on those readings, it updates the LED ring to reflect the plant's state. So this LED isn't decoration, it's the interface. Now, I'm not going to walk through every line of code. Instead, I want to focus on the parts that actually define the behavior of the device. Here, we read the soil moisture sensor and normalize it into a percentage. That makes it easier to reason about thresholds later. This block maps sensor values to colors. Now, dry soil gives us a warning color, and healthy conditions give us green. Now, the important thing is that the LED reflects state, not raw numbers. Even though this device works entirely on its own, every reading is also published over MQTT. Now, that means that this same hardware can later feed dashboards, automation, or AI without changing the circuit. Right now, the soil is dry and the LED is telling us exactly that. Now, as the moisture level rises, there it is, green. The circuit is responding to the real world, not a simulation. Now, as we saw earlier, under the hood, every sensor reading is also being published over MQTT. Now, I'm not using that yet, and that's on purpose. So this video is about getting the physical truth right first, okay? Now, in the future video, we'll use this same data stream for higher level behavior. Drop a comment below if you'd like to see more of the code. I'm happy to share that if there's interest. So this is the foundation, a plant sensor that works quietly, reliably, and honestly. Now, in future videos, we'll build on top of this, refining the hardware, designing enclosures, and eventually connecting this data to more intelligent behavior. But none of that matters if the physical layer isn't solid. Thanks for watching.